Okay, hello everyone. In the previous class, we have calculated some of the most important parameters in HEC-HMS by calculating the basin model, uh, basic, the sub-basins, and we have the reaches and we have the sink. We have already discussed in the class one what they are actually. Then we have also set it the dam. We have created some of the parameters that we can see over here, the icons, reaches. We can see first we have calculated the terrain, then fill sinks, sink locations, flow direction, flow accumulation, all of that, and then we have these parameters over here. You can just click here and you can see that we have uh, calculated in the previous class. So now let's uncheck them and just check the identified streams, sub-basins, and the regions, because we're going to work on them from now to onward. So if you can see that we have three sub-basins over there, the sub-basin 1, 3, and the 5. The two sub-basins I have deleted them. So if you can see from you can see from going to parameters and sub-basin area. From here you can see I have just one sub-basin showing there, and you can click on all elements, then you can see all the sub-basins and its area over here. And if you set them alphabetic, then you have the sub-basin and their area set it back alphabetically. So now you can see the area. If your area is less than maybe 1 kilometer square or maybe 10 kilometers square, you can just merge them with others like them. For now it's okay for me to have the area like that for all the sub-basins. So I'll just apply and close it. So if you click on sub-basin, any of the sub-basin, you can see a lot of methods are setting to none, but the loss method and the transfer method. Okay, okay, so the lowest method and the transform method are the most important method that we're going to use, and the method we're going to use is SCS curve number method. So we will calculate SCS curve number for both of them, the lowest method and the transform method, and we will set it the base flow method to none. So now we will calculate our curve number in ArcGIS Pro. HEC-HMS have some of the you can say that it have the tools to calculate the curve number, but I don't have now in that. I'm going to calculate it in ArcGIS Pro. So let's calculate it. Arc Pro. Before opening Arc Pro, make sure that you have exported your shape file in any of the folder, because we're going to use it in Arc Pro. And the next thing is go to the parameters and go to the lowest method and come to the SCS curve number. Select the basin element and then set them alphabetic. So now you can see that we have initial abstraction, curve number, and the impervious are set it. These are set it to 0, and these are don't have any number. So we're gonna put this first curve number, and then we have initial abstraction in the impervious. Okay, so now just close it and come to the ArcGIS Pro. For SCS curve number, I have already created a okay. So now we can add the data from here. Go to your folder that from where you have saved all of the data. I have downloaded in here. So go to there, and I have shapefile here. So now I have the shapefile same as it is. So let's just set its boundary and untick this. So now I have just edited the data. I have all the shapefile. Okay, so if your shapefile is not showing here, it most probably not projected. So if your shapefile is not in your own area, you can first select the projection and then you can come here. So, and if it is on its own place, you can just go as it is and then open the, and now open your attribute table, and you can see that we have all the parameters here. We have all the sub basins and we have other parameters too. So let's uh, sort ascend, and now we have ascending all the information. So now I will calculate the SCS curve number, and for that just go to your add data and HEC-HMS data, the data I have provided, and you have the CN grid. Just say it okay, and it will add after some time. Okay, so now you can see that my CN grid number is added over here. And now let's classify it as so you can use unique values over here, and yes, and then we have, just open this. Okay, so we have a curve number over here, and then and now we're going to calculate SCS curve number for all of our area. So for that, go to your analysis and tools, and from here search the tool zonal statistics as table. Here is it. Now just click it. Okay, so the input is shapefile, the sub-basins that we have created, and the zone is we're gonna use name, add as it is, and then we have raster value CN grid. We have the sub-basin 1, 2, and 3, its name, so that's why we're gonna use name over here. And then you have the CN grid raster. Just cross it and come here and just say it zonal statistics, and you can also select its folder number, or you can also select the folder, and then we have the statistics type from all. We just want the mean value because we want the mean for that, we also want a mean value for that, and we also want mean value for that. We are basically looking for the mean values. So just run it. Okay, so now we have, the zonal statistics table, and just right click it and open, and now you can see the mean values over here. So we have mean values for each subbasin is just sort ascending, and we will just now put these mean values into the HEC-HMS table. I just copy it from here and then open the Excel, and from here open the new file and just paste it here. I will just delete them. Okay. Now we have the zone count, the count, and the mean value. So we can select it as 80, and I'll just copy it from here. So I'll just copy it and go to your HEC-HMS, and then you can just go to the parameters, laws, SCS curve number, just say it as a basin element and alphabets, and now you can just paste it here. And if you see over here, they are just pasted correctly. So here's how you can calculate the curve number using HEC-HMS shapefile and ArcGIS Pro, the CM grid. Okay, so now if you look at the curve number, we have just calculated it, and for now we will see how to calculate the lag number over here. So for lag number is, so first of all we have a formula for calculating the lag method. So for according to that, lag time. Okay, so this is the formula. So we're gonna calculate uh, time of concentration by this, and then we will calculate the lag. We have the TC is the time of concentration, and this is the expression for the time of expression. So we have the L is the lag, here is the L flow length in feet, and then S plus 1, the S is the maximum potential retention. Then we have the L flow length, Y average watershed land slope percent in percentage. Okay, so now it gets back to here and just cross it. Okay, so we have just deleted the SCS curve number. Let's just copy it and paste it over here by saying it basin element and alphabets, and then here. Now just apply and then close it. Then it's not gonna delete. And then go to the parameters and then go to characteristics. Then you will see the table. Okay, so we will just copy some of the columns from here to paste it to Excel file. Just delete them. Yes, and name it as CN. This is the area we will use as it is. Then we will have flow length, that is in kilometer, and slope is Y, and then we will have another parameters. And make sure that you have sorted them as a 1, 2, and 3. So 1, 3, and 5, they are just same. Just copy them, copy and paste them here. And now let's get the slope. Go to your HEC-HMS and basin slope, copy and paste it over here. And make sure that your sub-basins must be alphabetically sorted. So now we have the curve number, we have the longest river path, and we have the slope. Then we will calculate the S. Here we have the S, this one maximum potential retention. The formula for that is is equals to 1000 divided by this and Cn, and then we have minus 10 minus 10. Now we want L in feet, and for that we will calculate L times 3208.84. Now our length is in feet. And now y is slope. We want y in percentage, so let's calculate this in percentage. So for percentage we will simply multiply it with 100. Okay, so now we have all the parameters for that. Now we can calculate this by we can calculate the time of concentration by using this formula over here. Let's calculate this. So we have the TC, and then we have a formula that is equals to, we will use L, that is flow length in feet, which is over here, and then the power is 0.8. Now you can see we have do this. Next step is to multiply this S plus 1 power 0.7. So we have S plus 1, and then we have the power of 0.7. Okay, now we're gonna divide it with 140 multiply y power 0.5. We're gonna divide it 140, and then we have the y is over here. Okay, multiply it with y, and then we have the y power 0.5. So we have 0.5. So just enter it, and now we have the time of concentration over here. So this is how we can calculate the time of concentration. Now let's calculate the lag. And for lag, so now we can calculate lag, and here lag is in hours, and then we can calculate lag that we're going to use in HEC-HMS in minutes. So for lag, we're gonna multiply it with the 0.6. You can just multiply this with into 0.6, and then we have this into 60 per minutes. So this is how we can calculate lag in minutes and the time of concentration by getting all the values from HEC-HMS. So let's just paste them in HEC-HMS. I'm just copy them and go back to HEC-HMS, parameters, and transform SCS hydrograph and basin element alphabetic. We have time lag in minutes, just paste it. We have 135, apply and close. Now if you go over here and just apply it and close it, Now go to your, and just go to sub-basin and go to the lowest method. We have the curve number over here, and when you go to the transform method, we have the lag time. We have a lag time and a proper lowest method over there. So we have the initial abstraction still empty. So now let's so go to compute. Now go to your parameters and loss, SCS curve number, basin element and alphabet. So I'll just put 0 for the initial abstraction for now, and for the impervious I will apply